Hello, and welcome to the tutorial on par interest rates. In this tutorial, we'll see how to derive the par interest rate on a bullet bond or other fixed rate financial instrument with a bullet final payment based on the discount factors. Let's start by reviewing what a discount factor is. Recall that a discount factor is the price for a single unit of currency, it could be $1 or €1, due on a future date. Discount factors on different dates will, of course, have different prices, and the discount factors also depend on the currency and the borrower. A single fixed cash flow due on date T, for example, CFT, is valued simply by multiplying it by the corresponding discount factor. And financial instruments with multiple fixed cash flows are valued by summing the values of the individual cash flows. Finally, the discount factor for a given maturity applies a corresponding spot interest rate and vice versa. Now, when working with discount factors, sometimes it's convenient to have another statistic called the annuity factor. So the annuity factor is simply the sum of the discount factors. So we see in the table, in the chart here, we've got three units of currency, one per year, and they each have a value corresponding to discount factors for those years. And the annuity factor is simply the value of all three together. Now note that even though it's called annuity, it is actually relates to the number of periods. So if you have semi-annual periods, you would need to evaluate the semi-annual discount factors. So let's consider a problem and look at an annuity with annual payments. So here in the graph, you see again three cash flows of a single unit of currency, and they have corresponding discount factors of 0.9, 0.8, 0.7. Now, what is the annuity factor for the three? It's just the sum of them. So pause for a second and think about what that is. Okay, so it's just adding the three together, nothing more difficult than that. So you're basically asking, what is the value of receiving $1 in year one, $1 in year two, and $1 in year three? And we simply add up those $3 in the three different years, and we come up with an annuity factor of 2.4. So that means that an annuity paying $1 per year for 3 years has a value of 2.4. And so if we had an annuity that paid $4 per period, what would its value be? Well, we just multiply $4 times the annuity factor. So once we have the annuity factor of 2.4, it's just 2.4 times 4, or $9.6. Now, if we have semi-annual cash flows, or an annuity with semi-annual payments, so note that this annuity is actually paying $2 per year, $1 every 6 months. And we want to know what is the annuity factor for, and there's different notation that can be used, but 3 by 2 is a convenient way of showing 3 years times 2 payments per year, so it'd be 6 semi-annual periods. So in the table, you see the value of the discount factors corresponding to each of those periods, 1 through 6, or years 0.5 through 3. So what would be the value of an annuity making those 6 payments of $1 every 6 months? Okay, so it's just the sum of those numbers. So if you simply take these 6 numbers and add them together, you will get 4.95. And notice that's bigger than the 2.4 we got for a 3-year annuity paying $3 over 3 years. This is $6 spread over 6 years. And so if we ask what is the corresponding value of a 3-year annuity paying $2 per period, we would multiply that $2 times the A of 3 by 2. Or 990. Notice that's a little bit more than the value we got in the previous problem, which was having annual payments of $4. Here we're getting semi-annual payments of $2, and that's just reflecting the different discount factors, but more importantly that you're getting half of the payments a half a year sooner than you did in the other case. Now, we've looked at before valuing a bullet bond simply based on discount factors, but we can use the annuity factor to make the equation even simpler by recognizing that the coupons themselves are an annuity. So if we multiply the coupon by the annuity factor, and then we add the value of the final bullet payment, we get the value of the bond. So if face value is $100 and we have a coupon rate, we multiply that by the annuity factor, and then we add to that the discount factor, which is represents the value of the final principal payment. So let's look at a problem dealing with this. So let's say we have these same discount factors again, 0.9, 0.8, 0.7, and then we have annuity factors corresponding to each of these periods. So 2.4 you should recognize was the 3-year annuity factor corresponding to 3 annual payments of $1. And we want to use this to value our bond with a face value of $100 and a coupon rate of 10% per period. So how do we do that? Well, $10 is our annuity, so we're getting $10 every year for 3 years. So we multiply that by 2.4, and then we're getting $100 at the end right here. So we multiply that by the 0.7 corresponding to this discount factor. And we're getting the same result as we would get if we multiplied each of these cash flows by each of the discount factors. Now, if we wanted to value now a $15 bond, it's very simple. We just instead multiply $15 by 2.4 instead of $10 by 2.4. So that additional $5 by 2.4 translates into this additional value, which is why we get 106 instead of 94. So let's go now to the par rate. So up till now, we've been assuming we have all the cash flows and we have discount factors and corresponding annuity factors, and we want to know what the value is. Now the par rate's turning this question around a bit, and it's assuming we know the value is par. So the value is 100. And we know that the final bullet is 100. We know each of the discount factors, but we don't know what the coupon should be. So we want to derive the coupon such that it will give us a value of par. So how do we do that? Well, let's go back to the formula for a bullet bond with a face value of 100. So that's 100 times the coupon rate times the annuity factor plus the discount factor. So this sum here multiplied by 100, which is the face value of the bond, will give us the value of the bond. Now, if we're saying the bond has a value of par, we're saying V is 100. We know that. And so now we can look at what these other things are. And we're assuming that we know that we're looking for a single coupon rate, C equal to CPN. And so we can rearrange to solve for that rate, what that is. So we're assuming CPN here corresponds to the coupon rate corresponding to an N-year or an N-period bond. And so we've just rearranged this formula. You notice the hundreds cancel out, so that's why they don't come over here. And it becomes very simple. 1 minus the discount factor for N, so that's representing the final payment of the bullet and maturity, divided by the annuity factor. And that will give us the coupon. So let's look at a problem. So let's say we're given, we have the spot rates. We derive from the spot rates the discount factors. And we can derive from that very easily the annuity factor. So the annuity factor for 1 year will just be the same as the discount factor, since we're just summing one discount factor. This annuity factor here will be the sum of these two, and then this annuity factor here will be the sum of these three. And this is the formula for the coupon rate. So if we're looking for the first coupon rate, well, DFN is 0.9479, and AFN is also 0.9479, so we get 5.50%, which is the same as the spot rate. Now, if we're looking at the second year, we're going to use a different discount factor, this one here, and then, of course, the annuity factor isn't the same as the discount factor, and we get 6.47. And then if we do it for the third year, we're just applying the same formula again, 1 minus 0.8106, and then divided by this, which is the annuity factor, we get the par rate. So we're able to derive from these discount factors what the par rate would be for each of these maturities. And really what this means is these are the rates that if we discounted at these discount factors and annuity factors would give us back a value of par, or 100. So let's summarize. We recall that the discount factor is the value of $1 or 1 unit of any currency due on a future date. The annuity factor is the value of $1 per period out to a certain future date, and so it's equal to the sum of the discount factors corresponding to each annuity payment. The par coupon rate is the interest rate on a bullet bond or another financial instrument with a bullet payment at maturity that will have a market value of par based on those same discount factors. And so we're able to derive that based on the discount factors using this formula here. So that's it on calculating the par coupon rate from discount factors. Thank you for listening.